Hi everyone, for today's lesson we are going to learn how to solve linear systems algebraically. In our last lesson we learned how to solve systems using graphs, and we characterize those graphs by either consistent and dependent, inconsistent, or consistent and independent. So for our warm-up for today, I would like you to please go ahead and sketch an example of each of the following. When you have an answer, please go ahead and restart the video and we'll see how well you did. Okay, let's go ahead and look at letter A. A consistent and dependent system is a system in which a line is on top of another line. So you'll see that you'll have a line on top of another line. And this system, or these two lines as a part of this system, intersect at every single point. They have infinitely many solutions. An inconsistent system is a system that has two parallel lines. There is no point of intersection, so there is no solution. They are considered inconsistent. And finally, a consistent and independent system is where you have two lines that are going in independent directions and they only cross at one point. So there is one solution. Just an ordered pair that we call XY. So for this lesson, you will still need to categorize systems as either consistent and dependent, inconsistent, or consistent and independent, depending on the type of solution that you end up getting. In yesterday's lesson, or in the last lesson, where we were solving systems graphically, we found that sometimes our point of intersection wasn't a very nice number. And we were kind of guessing, it kind of looks like it's 2 and 2.5 or whatever it was that we were graphing. And so the nice thing about solving systems algebraically is that no matter how nice or not nice the final answer actually is, we can guarantee that we can actually find that intersection as long as our algebra is correct. So our learning objective for today is for you to be able to say, I can solve a system of linear equations using multiple approaches, algebraically. And I can write and solve a system of linear equations to solve a real-world problem. So there are multiple approaches. Well, there's two approaches algebraically. There is the substitution method and the elimination method. Using either method, well, it just depends on what kind of equations that you have. I'm open to you using just one or just the other, as long as you're consistent, but there are strategies for when to use which method and which approach, and we'll talk about that in today's lesson. So let's go ahead and talk about the substitution method. I think that the substitution method is the best when you look at your two equations and one or more variables have 1 as the coefficient. So if you see that you have like an x or a y alone, like in this problem, we have x plus 2y is equal to -2. X has a coefficient of 1. Whenever you see that, maybe the substitution might be the faster or better approach. So let's go ahead and look at the steps. The steps for the substitution method goes like this. Step 1, you want to solve one of the equations for one of its variables. So you want to pick which equation would be the easiest to work with first. It's always nice to label your equations 1 and 2. And looking at equations 1 and 2, I like equation 1. What's nice about equation 1 is that it would be easy to solve for x very quickly. So I'm going to write down x is equal to 2y, x plus 2y is equal to -2, and I'm going to solve for x by subtracting 2y on each side. And I end up with x is equal to -2y minus 2. Cool. I just solved one of my equations for one of its variables. Step 2. I'm going to substitute the expression from step 1. So I'm going to substitute the -2y minus 2 into the other equation, and I'm going to solve for the other variable. So I'm going to substitute -2y minus 2 in to x in the second equation. So what does that look like? Well, here is step number 2. In step number 2, I have 3 times -2y minus 2 plus 4y is equal to 6. Why does this work? Well, we're trying to find a solution to the system. And a solution to the system, assuming that there's only one solution, is one ordered pair, one x and one y value that satisfies both equations. So we're trying to find one x value and one y value where it doesn't matter if you plug it into the first equation or the second equation. It's going to work for both. So that's why we're allowed to do the substitution method. So I'm going to distribute the 3 to each term, and I end up with -6y minus 6 plus 4y is equal to 6. Combining my like terms, I end up with -2y minus 6 is equal to 6. I'm going to add 6 to both sides, and I end up with -2y is equal to 12. Dividing both sides by -2, I find that y is equal to -6. Cool, I ended up with a y value. And what that tells me is that I'm going to end up with an ordered pair as my final answer. So I'm going to put -6 into the y position. And now I'm ready to do step 3. Step 3 says substitute the value from step 2. So I'm going to substitute y equals -6 into the revised equation from step 1, and I'm going to solve. So my revised equation from step 1 was the x is equal to -2y minus 2. So this is step number 3. I have x is equal to, and I'm going to let y equal -6, and I'm going to write -2 times -6 minus 2. And I end up with x is equal to 12 minus 2, and so therefore x is equal to 10. So now I need to check my answer. That's step number 4. So anytime you end up with just a plain ordered pair, you need to check that solution algebraically by substituting x and y into both equations. So we have to put it into both, and so here is step number 4. So my first equation is x plus 2y is equal to -2. And I'm going to let x equal 10, and I'm going to let y equal -6. So is 10 plus 2 times -6 equal to -2? Is 10 minus 12 equal to -2? Why, yes, it is. Now I'm going to substitute 10 -6 into 3x plus 4y is equal to 6. Is 3 times 10 plus 4 times -6 equal to 6? Is 30 minus 24 equal to 6? Why, yes, it is. So because I've checked and proven that the ordered pairs satisfy each equation, I can say that 10 -6 is my solution, and this system is considered consistent and independent. So that is the substitution method. And remember, it's best to use the substitution method if one or more variables have just the number 1 as the coefficient. The other method is called the elimination method. And what's nice about the elimination method is that it's a lot faster and a lot quicker. And it's really helpful whenever you don't have 1 as the coefficient. So here are the steps. Step number 1. We need to multiply one or both of the equations by a constant to obtain coefficients, numbers in front of the variables, that differ only in sign for one of its variables. So what that means is that your goal is to make it so that the variables have the same number in front, but they're opposite signed, like a 2 and a -2, a 4 and a -4, a 5 and a -5. You need to, or a 10 and a -10. You've got to multiply and manipulate the equation so that we have opposites. I would recommend in this problem looking at your coefficients and seeing if there's a relationship. I can see that 2 and 4 are related to each other. 5 and 2 are not as related to each other. Could I work with 5 and 2? Sure. But I'm thinking that it might be easier to work with the 2 and the 4. I know that I can multiply 2 times 2 and it'll equal a 4. But I want them to be opposite in signs. So what I'm going to do is I'm going to put parentheses around both sides and I'm going to multiply both sides by -2. And I'm going to put my answer just below. And -2 times 2 is -4x. -2 times 5, that's a -10y. And that's going to be equal to -2 times 14, which is -28. And now what I'm going to do is go on to step number 2. And it says, add the revised equation from step number 1. Combining like terms will eliminate one of the variables. Then we're going to solve for the remaining variable. So what we're going to do here, if it helps, we can rewrite these equations as -4x minus 10y is equal to -28. That's my revised first equation. And then I have 4x plus 2y is equal to -4. And now I'm going to add, going straight down. By doing that, the 4x's eliminate. -4x plus 4x cancel away, leaving us with -8y is equal to -32. Dividing both sides by -8, I find that y is equal to 4. Cool. I have a y part. That tells me that I'm probably going to end up with a consistent and independent system this time. All right, so that is 4. So now I'm on to step number 3. It says substitute the value obtained in step 2 into either of the original equations and solve for the other variable. So I'm going to let y equal 4, and I'm going to pick whichever equation makes me feel happy. And I like the first equation. Why? Because it's working with all positive numbers, and I like working with all positive numbers. So I'm going to go 2x plus 5y is equal to 14, and I'm going to let y equal 4. So I'm going to go 2x plus 5 times 4 is equal to 14. So I have 2x plus 20 is equal to 14. Subtracting 20 on both sides, I end up with 2x is equal to -6. And dividing both sides by 2, I have x is equal to -3. Cool. I have an ordered pair, -3, 4. And now I need to check my answer, and that's what step 4 is. Step 4 is you need to check the solution algebraically by substituting x and y into both equations. So here's my check step. I'm going to write 2 times -3 plus 5 times 4. Does that equal 14? Is -6 plus 20 equal to 14? Why, yes it is. So now I'm going to check the other equation. Is 4 times -3 plus 2 times 4 equal to -4? Is -12 plus 8 equal to -4? Why, yes it is. It works out for both equations, so that tells me that this system is consistent and independent. Let's go ahead and flip the page. For example number 3, we're going to practice solving the system using the elimination method. If you want to try this one on your own, you're welcome to. If you want to follow along with me, that might be a good thing too. Here we go. So looking at this system, I noticed that, first thing I need to do is I need to have my coefficients be the same number. And what I've noticed is that 3 and 5, they're not related. And 4 and 3, they're not related. So that tells me that I'm going to have to manipulate both equations. And so therefore, it's just my choice, whichever variable I want to eliminate. I'm open to eliminating either of them. So why not I go ahead and eliminate the x's? The x's come first. It really doesn't matter. So I'm going to select the x's. You're more than welcome to select the y's too. You should still end up with the same exact answer. So multiplying 3 times 5, I know that that will equal 15. So I can probably change both of these coefficients to be the number 15. One would be a positive 15, and the other one would be a negative 15. So in order to change 3 to become the number 15, I'm going to multiply the top equation by 5. And by doing that, I'm just going to write it down here in this space. 5 times 3, that's 15, so that's 15x. 5 times 4, that's minus 20y. And this is going to be equal to negative 37 times 5 is equal to a negative 185. Next, I'm going to multiply the bottom equation by 3 in order to change my coefficient to be a 15. So 3 times negative 5 is negative 15x. 3 times 3 is 9, so I plus 9y. This is equal to 14 times 3, which is 42. At this step, we're going to add going straight down, and my x's are going to eliminate, leaving me with negative 20 plus 9y. So negative 20y plus 9y is equal to negative 11y. And this equals negative 185 plus 42 is equal to negative 143. I'm going to divide both sides by negative 11. And when I do that, I find that y is equal to 13. Awesome, I ended up with a piece of an ordered pair, so I'm going to put 13 in the y position, and now I'm going to find x. So I'm just going to solve 13, I'm going to plug 13 back into one of the equations. It doesn't matter which equation you choose. I like positive numbers, and 37 was a pretty big number, so I think I'm going to work with the bottom equation. So I'm going to write negative 5 times x. Oh, let me write that again. Negative 5 times x plus 3 times 13, that's going to be equal to 14. So I'm going to solve for x, and I'm going to write negative 5x plus 39 is equal to 14. I'm going to subtract 39 on both sides, and when I do that, I end up with negative 5 is equal to negative 25. Negative 5x is equal to negative 25. And I'm going to divide both sides by negative 5, and I find that x is equal to 5. We always write our answers as ordered pairs. So sometimes kids will get answers incorrect because they don't write their final answers as ordered pairs. Please make sure that you do that. Just putting that out there. And now we need to check our answer. So I'm going to plug 513 back into each original problem. And I'm going to write 3 times 5 minus 4 times 13. Does that equal negative 37? Is 15 minus 52 equal to negative 37? Well, if you need to get out a calculator to verify that, you're welcome to. But it actually does. So now I'm going to check the second equation. Is negative 5 times 5 plus 3 times 13, is that equal to 14? Is negative 25 plus 39 equal to 14? Why, yes, it is. Therefore, 513 is indeed the answer, and we're going to call this consistent and independent. For example number 4, I would like you to choose whichever method that you would like, and I want you to go ahead and do this one on your own. Please pause the video, and when you have an answer, please restart the video, and you'll see how well you did. All right, let's go ahead and look at number 4. For this problem, you can choose whichever method that you want. Whoa. Sorry about this, guys. All right. So we need to choose whichever method that we want. So the nice thing about this problem is that I have a variable that has a coefficient of 1. You can use the elimination method. There's nothing wrong with that. But because we have a coefficient of 1, I would recommend the substitution method. So I'm going to use the substitution method. And I'm going to write x minus 3y is equal to 7. And I'm going to solve for x by adding 3y to both sides. And I end up with x is equal to 3y plus 7. So now I'm going to substitute 3y plus 7 in for x into the second equation. So that's going to be 2 times 3y plus 7 minus 6y. Is that equal to 12? Or I'm sorry, and that's going to equal 12. So now I'm going to distribute the 2 to each term to make this 6y plus 14 minus 6y is equal to 12. 6y minus 6y becomes 0y. They cancel away, and we're left with 14 is equal to 12. But 14 does not equal 12. They are completely different numbers. I'd much rather have $14 in my pocket than $12. They're not the same. And what that means is that we have no solution. These are parallel lines, and we call this system inconsistent. Let's go ahead and look at letter B. For letter B, I probably use the elimination method. And looking at 2 and 5 and 6 and 15, I would probably work with the 2 and the 5 because those are smaller numbers. Those are easier numbers to work with. And I know that both 2 and 5 can go into the number 10. So I'm going to change the coefficients to be a 10 and a negative 10. So I'm going to multiply the first equation by 5 on both sides. And I'm going to multiply the second equation by 2 on both sides. So I'm going to come up with my new equations over here, and I'm going to make this 10x minus 30y is equal to 60. And then I have negative 10x plus 30y is equal to negative 60. I'm going to add, going straight down, and 10x minus 10x cancels away, and negative 30y plus 30y cancels away, so I'm left with 0 on this side. And 60 minus 60, that's equal to 0. And I end up with 0 equals 0. This is true. 0 does equal itself. So what that means is that we have infinitely many solutions. And this is called consistent and independent. I'm sorry, excuse me. Consistent and dependent. Consistent and dependent. We have one more problem and then we are finished with this lesson. So this is a story problem. And it says, an adult ticket for a matinee costs $1 more than a children's ticket. When 350 adult tickets and 200 children's tickets were sold, the total revenue was $2,550. Find the cost of an adult ticket. So whenever we're given these types of problems, we need to define our variables and write a system of equations that actually models the system. So typically the last statement will tell you what you're trying to find, and it'll help you to define your variables. So we want to find the cost of an adult ticket, and we want to find the cost of a child's ticket. So those are our two unknowns. I'm going to let x equal the cost of an adult ticket. And I'm going to let y equal the cost of a children's ticket. Next, I'm going to write my system. It says an adult ticket for a matinee costs $1 more than a children's ticket. So that means that the cost of an adult ticket is equal to the cost of a child's ticket, but you got to pay $1 more. So x is going to be equal to y plus 1. Next, we are told that if you pay for 350 adult tickets and 200 children's tickets, the total revenue is going to be $2,550. So this is our system. I have two separate equations. And what's nice is that I already know what x is going to equal. So I'm going to use the substitution method, and I'm going to substitute y plus 1 into y into the second equation. So I'm going to solve the system, and then I'm going to use a complete sentence to describe what the solution means in this situation. So I'm going to write 350x plus 200 times y plus 1. That's going to equal $2,550. I'm going to get rid of my parentheses by distributing 200 to each term, and I have 350x plus, plugging this in, totally screwed that one up, geez Louise. I'm plugging this in for x, not for y, geez Louise. Let's try this again. We have 350 times y plus 1 plus 200 times y is equal to 2,550. Sorry about that, guys. Jeez Louise. One of the consequences of doing math in pen. All right, does that make sense? We know what x is. We're going to substitute it in for x into that equation. And I'm going to solve for y. So now I can actually combine like terms in this next step. So this is 350y plus 350 plus 200y. That's going to be equal to 2,550. Combining my like terms, I end up with $550 or 550y plus 350. That's going to be equal to 2,550. At this step, I'm going to subtract 350 on both sides, and I end up with 550y is equal to, well, this is going to be equal to 2,200. Dividing both sides by 550, we end up with y is equal to 4. Well, y is the cost of a children's ticket. It's not the cost of an adult ticket. So that's what y means. But that's not what we're trying to find. We're trying to find the cost of an adult ticket. So an adult ticket, that's going to be equal to x, or x is equal to 4 plus 1, which is 5. So our answer is it costs it costs $5 for an adult ticket. And if you want to write down what y means, you can. You can say it costs $4 for a children's ticket. And that is the end of this lesson. If you have any questions over how to solve a system using substitution or elimination, or if you have any questions about this lesson in general, please feel free to email me or talk to me the next time I see you in class. Otherwise, I hope you have a wonderful day.